In this video, we're going to talk about string data type. String in Java is nothing but collection of characters, just as a word in English language, which is collection of letters. This is how we represent a string in Java. Now, by taking a look at this statement, you may think that string is a primitive data type, but actually it isn't. String is a non-primitive data type or user-defined data type. So essentially, string is a class, and we're in fact creating an object of this class to be able to create this string. Well, we're not explicitly creating an object using the new keyword, but Java does that for us. So this statement in here can be represented in this manner as well. We have a character array which has all these characters A, P, P, L, E, and we're sending that character array as an argument to the constructor of string class. These two statements in here does exactly what this single statement does. For the convenience of the programmer and to save time and effort, Java designers gave a shorter way of representing these two statements. So let me comment them out. Save the file. If I try to run this program, then we would see Apple as the output. Let's do that. Let's comment this line and try to run the program by uncommenting these two lines. We would see the same output. Great. So why Java designers decided to have string as a non-primitive data type? That's because it gives us lots of flexibility. There are lots of methods in this class string that we can utilize for our own convenience. For example, let me just uncomment all these lines of code. Save the file. Now, by calling a method inside that string class called length, we can get the length of that string, whatever the string is. Similarly, we can convert that string to uppercase by calling this method called toUppercase. We can replace a character. We can find the position of a certain character. We can also extract the substring of a string. For example, in the string apple, we might want to get a substring like PLE or something like that. Now let's see how this program works. Let's run the program. Here it is. We're able to utilize that string class and perform certain operations on the string. There are many such methods in string class. For more information on them, you can refer to this link. Actually, you don't have to go inside this link. If you just use the dot operator, your IDE will suggest what are the methods available that are of public. And we also have explanation of each and every method. So you can just go through it. It's pretty much self-explanatory. Let's undo and save the file. In our next video, we're going to talk about string as immutable. Open the class called string immutable under the package string package. Let's expand it. Can you make a guess on the output of this program? We have a string here. We're trying to convert that string to uppercase and we are printing it. Would the output be uppercase apple or would it still be apple? Alright, string is said to be immutable. That means once the string is there in the memory, nobody can ever change it. And when I say string is immutable, I'm only talking about the literal, the right hand side of this equal sign. We can always change to which object this reference type points to. If I run this program, you will not see the uppercase apple. You would still see the apple, lowercase apple. Let's run the program. Now, before you start yelling, what the hell is going on, I'll take you to the whiteboard and explain you in more detailed fashion. Let's go there. So again, we have our stack memory and heap memory. Now this statement in here, as we've looked at in our previous example, will essentially create a new string object using the keyword new. So the reference type would reside in the stack and will point to an object inside the heap memory, which in this case it would be string apple. This is not the case in case of string. What actually would happen is we have a special memory inside this heap which is called string pool, and this string object would be created in here, and this reference type would point to this object. So why do we have a string pool? You will understand that in a minute. You will also understand why string is immutable. Let's say I have another statement that says string str2 equals apple, the exact same string what we have here. So this being reference type, we'll have it inside the stack str2. This statement will not create a new object inside the string pool. Instead, it would just point to the exact same object because they're essentially holding the same exact string, apple. Now, can you guess why Java designers made string as immutable? That's because let's say we have a statement that says str dot to uppercase. If the string is mutable, then this statement will make changes to the actual object, and this will impact str2 because it is pointing to the exact same object. Likewise, there could be many number of string references which are pointing to the same object across all the programs. So we cannot let the programmer make changes to that string at any given point of time. So this answers why string is made immutable. But why do we have string pool in here? By now you should have understood it. We have string pool primarily to save the memory. So these two string reference types are pointing to the same object. We didn't create two different objects for these two instructions. That saves the memory of one object. If we have 100 strings created which are holding the same name, same string, apple, then all of them would actually point to the single object in the string pool, and it won't create multiple objects. So there's a great memory advantage. But just in case if you decide to not bother about memory, and if you decide to create string object in heap memory, there is a way to do that as well. So this is how you do that. String s1 equals new string, and then you will pass the string as an argument to the constructor of this class, which would be, say, banana. This instruction will create an object inside the heap memory, as well as a copy would be created inside the string pool. Now let's say we have another statement, the exact same statement but with a different name. New string say banana, ignore the typo. Now this will create another object inside the heap memory. So although the strings are same in this case, two different objects would be created in the heap memory. Now let's say we have one more statement, say string s3 banana. Would this create a new object in the string pool? It won't, because by doing this statement we've created an object in heap memory as well as in the string pool. So this statement, the s3, will point to banana in the string pool. Hope that makes perfect sense. Let's go back to our program. But before that, let me just show you one of the security threats had it been the case that the string is mutable. Let's say you have two computers. Computer 1 is authentic and computer 2 is insecure. It has some malicious software in it, and you don't want to access that machine from your program. In your program, you have a method that says connect, and you're going to send the IP address or the system name as a parameter. Your program will check to see if the connection is secure. If it is not secure, then you're going to exit. If it is secure, then you're going to go ahead and connect and do some operations. Now let's say you sent argument as computer 1. This check will pass because it's a good computer. But before you reach the statement connect, some other program would modify this string to computer 2. So you're actually connecting to a computer which has malicious content in it. This is a serious security threat. Thankfully, string being immutable, nobody can ever change this, computer 1. Hope that clarifies. Let me just uncomment this code in here. In our previous example, we have already looked at the use of double equal sign for primitive data types. But this operator will also help us in checking to see if these two reference types are pointing to the same object or not. Can you make a guess on the output of these three instructions? Okay, this line will create a new object in the string pool and has the reference A. We have another reference B and will actually point to the exact same object created in the string pool. So hence the output of this line would be true. These two reference types are actually pointing to the exact same object in the string pool. Coming to this instruction will create a new object inside the heap memory, and this instruction will also create a new object in the string pool. This will point to the object residing in the string pool. But these two are two different objects. One is in the heap memory, one is in the string pool. So this statement would return false. Now how about this? These two are two different objects in the heap memory, and hence this would be false. Let's try to run the program. There you go.